Hello there, fellow mainframers and computer performance analysts. Welcome to Mainframe Performance Fundamentals and Concepts, and today we are going to discuss measurements. In particular, what I want to do is introduce you to what I consider probably the most fundamental and basic of all mainframe measurements that all performance analysts need to understand, all mainframe IT managers need to understand, all capacity planning people, and anybody who's interested in mainframe performance. What is that measurement? Today we are going to talk about physical CPU utilization of your machine. Hi everybody, my name is Peter Enrico of Enterprise Performance Strategies, and I'm a co-creator of Pivotor. My team and I are here to help you get great workload performance while optimizing the usage of your system resources in the mainframe environment. Our education and our software are geared towards helping you get better performance results and faster. We're here to help you do what we do. Now, any of the references I give in this video will be linked in the references below, and if you haven't done so already, click the subscribe button. So let's get into it. So as I mentioned, today what we're going to talk about are measurements. And the measurement we're going to be talking about is what I consider probably the most fundamental measurement of all of the mainframe measurements. It's the number one go-to measurement that typically, computer performance analysts look at first, operators look at, IT managers look at, capacity planners look at, because it is so fundamental to the overall performance of the environment. What is that measurement? The measurement we're going to be discussing today is the physical CPU utilization of the machines that our systems and workloads are running on. As I had mentioned in other videos, is in the mainframe environment we have a machine, also known as a CEC. And this physical machine has some number of physical CPUs on it. Now, the physical machine we tend to call a processor, as I mentioned, a CEC. Some installations have multiple physical machines. Many installations only have one physical machine. The point is that this machine tends to be your most expensive resource because it is where all the magic happens. So naturally, we want to understand, how busy is it? Now, as I said and mentioned in other videos, is we have our physical machine, we have our physical processors on that physical machine, and on that machine we have what's called a hypervisor named Prism, and Prism is what takes our systems, and each system has some number of what we call logical CPUs, and associates those logical CPUs to the physical CPUs. So it is our systems that are using these physical individual CPUs on our machine. So naturally, we want to understand, well, what is the overall CPU utilization of the machine, and how is that utilization divided up or being utilized by our different systems? And that's what we're going to look at when we look at an example of the report. Who is interested in this measurement? I already said, anybody who's interested in mainframe measurements is going to be interested in this particular measurement, because mainframe performance is fundamental to how much capacity and how that capacity is being utilized on the machine. What are some of the questions that this measurement could answer? Well, we're going to look at some examples of the report, but some of the most fundamental questions are going to be, well, how busy is the machine? What is the breakdown of that busyness by system? When are our peaks? When are our valleys? When are the areas where the machine is not being utilized? And is the machine overcommitted and always running at a high utilization? Now, when we look at this machine, we're going to look to see different patterns of activity, but first I want to go through what is the source of this measurement. Now, CPU utilization, or the physical utilization of the machine, can be found in a number of different monitors in a number of different areas in the mainframe environment. The source from the measurement, the source of the measurement itself, is gotten from the machine, and the machine, which is running Prism, has the ability to collect that measurement and feed it back to the operating system. So the measurement itself comes from Prism, because it's the one who understands how the machine is being utilized. If you're looking for the source of the measurement in terms of your data, there's a lot of different sources, but in this particular video, I'm going to refer to the SMF Type 70 record. The SMF 70 record has partition data, what we call Prism data, and that is where we find this measurement. In fact, the measurement of physical utilization is not found in the SMF 70 record. It's the source measurement that we then use in a formula to calculate the physical machine utilization. What I'm showing here is the formula for physical utilization. In the SMF70 record, we have several measurements of interest that when we put into a formula will help us understand the physical utilization of the machine. For each LPAR, what we have is for each LPAR, for each logical processor, we have what's called the total CPU dispatch time that a logical processor was associated with a physical processor. So the point is, for all of our systems, for all of our individual logical processors, we have the total amount of time that a physical processor was dispatched. A logical processor was dispatched to a physical processor. We're going to take that amount of time and we're going to call that our total dispatch time. That's the top of the formula that we're looking at here. Below that, we divide simply by the duration of our measurement interval. In today's day and age, many of you have measurement intervals, SMF measurement intervals of 15 minutes or 10 minutes, but the point is you have a duration, whatever that duration may be. And you multiply that duration by the number of physical processors on the box. So the total formula for physical utilization is going to be the total dispatch time that all systems had their logical processors dispatched to a physical processor. We're going to divide that by the result of multiplying the duration of the measurement interval with the number of physical processors on the box. We take that calculation, multiply by 100% to get a utilization, and that's how we calculate physical utilization of the machine. So let's look to see what that looks like on an actual chart. And I'm going to bring up a chart now that we can look at to see what the physical utilization of the machine is. Okay, so what we're going to do now is we're going to take a look at some example measurements. And what I want you to look at here is a screen of some reports. Now what we're looking at is thumbnails or a series of thumbnails. And the specific report we want to look at is the one listed here, which is KEK Physical Machine CP Busy Percent, and it's by KEK serial number. Why by KEK serial number? It's because when we think of our physical machine, we think of the box itself, and IBM identifies each one of these boxes by a serial number. So naturally, what you want to be able to do is measure each individual machine. Yeah, you can always change it so that maybe, for your reporting purposes, you can put your own name in, maybe East Coast versus West Coast, Machine A versus Machine B. But for this particular report, I'm going to give you the serial number of the machine. Now, I'm going to pick one of these thumbnails, and we're going to look to see what this report actually shows us. Now, what the report is actually showing us is for 24 hours of period of time, what is the physical CPU utilization of the machine. Now when I say CPU utilization, as many of you know, you've heard me talk about in other videos, on the mainframe environment we have different pools of CPUs. We have our CPUs, we have our zIIP CPUs, and we have several other CPUs. In this particular video we're talking about CPUs because we just want to see how busy they are. Now what we're looking at here is a chart that if you look at the x-axis, we're looking at the date and time, and this is 24 hours worth of data, so it goes from midnight to midnight. And if you look at the y-axis, we're going from 0 to 100% because we're measuring what is the average utilization of the machine on a scale from 0 to 100%. If I go to the right-hand side, we see here that we have a number of series. And in this particular case, we're breaking down the utilization by individual system, what is also known as LPARs. Now on this machine, we have an LPAR called DevL01, we have an LPAR called ICF01, ICFT01, we have one called Prod01, and we have one called Test01. The physical is not an LPAR, and that's because we think of physical as being a bucket of time that we know that Prism is using to manage the entire machine. So we want to look at that, and we want to include that in our utilization as well, since Prism is using it. So let's look to see how we look at this machine. What we're looking at first is the profile of the chart, and when I say the profile, it's sort of the outline of the chart. And the outline of this chart is how busy the machine is. So visually we can see at times that this machine is at 100% busy or near 100%. We see during these periods of time here that the machine is low utilized, so that's available capacity. We typically see at the nighttime we have our batch cycle. That's probably what this utilization is here. During the daytime we see our sort of daytime utilization, and this is our early evening batch. What's happening on this machine is irrelevant for this discussion, but we see that the machine is utilized by several LPARs. Now what we also see by the different colors is the LPARs that are actually using it. So not only do we know the physical utilization of the machine, we also know the breakdown of that physical utilization by individual system. In this particular case, we see that the biggest LPARs are the prod LPAR, followed by the dev LPAR, and the other ones are very small, minor LPARs. Still using up CPU, but still minor LPARs. Now what we do is I tend to, in our product, we put these flyovers, sort of these post-its, to tell us more about the point. So let me find more about this individual point here. And what the post-it is telling us is that the brown area that we're looking at is the prod 01, and we see the number 93.03. What that 93.03% means is that this LPAR is physically using 93.03% of the physical resource of this machine, which is probably the majority of it. We go down, we see the second line is at 4:15 in the morning. We look at the next line down, which says interval, so now we know it's for a 900-second or 15-minute measurement interval. And we see that the cumulative total is 99.38% busy. Actually, if I go to the very top LPAR here, it'll go up. We see that this machine is 99.94% cumulative total. That's how busy the machine is of all the LPARs. And we see that at 4:15, that 93.03% of the utilization of the machine is due to this one LPAR. We see here that that's representing 2,511 CPU seconds that the logical processors on this LPAR would dispatch to the physical CPUs on this particular machine. So we think of that as our dispatch time. So what we can say now is that 2,511 seconds of dispatch time for this LPAR is representing 93.03 utilization for this LPAR. That's what percentage this LPAR is using of the machine. The final line is it tells us that this machine is a three-way machine, because sometimes when we look at utilization, okay, I'm 100% utilized. 100% of what? Am I looking at a one-way machine, a three-way machine, a 10-way machine, a 30-way machine? I don't know, but now we know that this 100% utilization is of a three-way machine. If we go down to the bottom, we see here that the second LPAR, DevL, at that same period of time is using up 5.95% of the machine. So this is our physical utilization of the machine, and we can get a lot of information out of it. I can go through that in other videos, but for now, understand that we're looking at how busy the machine is, at what periods of time the machine is busy, how that machine is actually being utilized by each individual system, and when our available capacity is. If I go to the next system, I'm going to hit the play button here. This is our second system. This second system has three LPARs, test 04, prod D04, and dev L04. And we can see that the major LPARs are the prod 04 LPAR, and we can see here that the dev L4 LPAR is the busy LPAR. Once again, we see that our nighttime batch cycle is probably the most busy, and this is our daytime cycle, and this machine tends to have more available capacity on it. So what we've looked at during this particular video is how busy a machine is. We're going to see in other videos how we can actually utilize this in terms of when we want to take advantage of these patterns. You know, what can I do when if I go back to the other one, when I have so much free space early in the night, but then I have this peak utilization in the late morning. Why is that happening? Probably it's happening, and I happen to know this environment, is that it's a well-tuned environment, and the data, the workload that they have to process in their batch cycle doesn't complete on another machine until this period of time, so they can't really utilize this period of time. Trust me, this particular installation would love to pull this processing in. By pulling it in and taking advantage of this white space, we can actually probably decrease this utilization, but that's not available on this machine. We can also look at other patterns of activity when one LPAR is busy versus the other. So for example, here we see on this particular machine that the development LPAR is not very busy at nighttime. It's not very busy during the day, but apparently some developers are doing work in the evening hours to take advantage of the fact that the machine is not highly utilized during the evening hours. And it's these types of patterns of activity that we want to look at. So I hope you enjoyed that. We're going to go through this measurement in more detail in other videos, but I want you to understand one of the most fundamental measurements you want to look at is how busy the physical machine is. And this is what this report is all about. Thank you.